least square regression line. Make sure you watch the videos for number 1, where we use StatCrunch to answer these questions. Number 2, a researcher uses a linear model to study the relationship between refined sugar consumption, calories per day, and the annual rate of major depression, cases per 100 people, for various countries. So the data lists several countries. The correlation coefficient between the two variables is 0.9445. The average sugar consumption among these countries is 340.83, with a standard deviation of 110.56 calories per day. That is the unit for the refined sugar consumption. The average annual rate of major depression is 4.27, with a standard deviation of 1.34 cases per 100 people. That is the unit for the annual rate of the major depression. Interpret the value of the correlation coefficient for this data set. We were given the correlation coefficient R equals 0.9445. This is almost close to 1. So we see that there is a positive upward relationship between refined sugar consumption and annual rate of major depression. These two variables are both quantitative variables. Positive, strong, because it's almost close to 1. So the direction is upward, positive. The strength, it is very strong. It is almost close to 1. B. Find the equation of the best fit line to predict the annual rate of major depression based on the refined sugar consumption. That is, we want to use the refined sugar consumption to make the prediction on the annual rate. Now, before we do that, let's answer part C. Is it reasonable to conclude that increasing the sugar consumption leads to a higher rate of depression? Explain. It is likely not. And that is because we cannot say for sure that consuming higher sugar amount will lead to higher depression rate. There are many lurking variables behind this, especially when we deal with depression. So even though there is a strong correlation does not imply causation. One does not cause the other, just because the correlation coefficient is strong. All we can say is that there is an association between the two. Not one leads to another. Again, especially in this context, depression is a very complicated subject. It doesn't depend on the sugar's consumption alone. Back to part B. To find the equation, this time we cannot use StatCrunch because we do not have the raw data. We were given the correlation coefficient R, the mean X bar, the mean Y bar, the standard deviation Sx, and the standard deviation Sy. So we will need to compute the slope and the initial value differently. To compute the equation y equals a plus bx, where b is the slope and a is the initial value, b is r times sy over sx, and a is y bar minus b times x bar. Y bar is the mean of the response variable and x bar is the mean of the explanatory variable. B is the slope that we found in the previous step. The explanatory variable is sugar. We would label this as x, and the depression rate is y, the response variable. Thus, the mean or the average sugar consumption is x bar, and x bar is given 340.83, with the standard deviation S of x is 110.56. The average annual rate of major depression is y bar, and y bar is given 4.27 with the standard deviation s sub y equals 1.34. The unit for x bar and s sub x is for the sugar consumption, which is calories per day. The unit for y bar or s sub y is the annual rate, which is cases per 100 people. We were also given the correlation coefficient R equals 0.9445. In this case, we were not given the raw data, so to compute y equals a plus bx, we would find b first. B is our correlation coefficient times the standard deviation of the response variable over the standard deviation of the explanatory variable first. And then we're going to use that b to find a. A is y bar minus b times x bar. Thus, b is 0.9445 times sy is 1.34 divided by s of x is 110.56. Put this in a calculator, we will get 0.01145. Usually we round it to 4 decimal places, but the numbers are very small, so I round it to 4 significant digits. Once we found b, we can find a. A is y bar. In this case, y bar is 4.27 minus b. B is the number that we just found in the previous step, 0.01145, times x bar, but x bar is 340.83. Put this in a calculator, we will see that this is 0.3675. Thus, the equation of the best fit line is y equals 0.3675 plus 0.01145 x. Oftentimes, we use this equation to predict the response variable, so we use y hat. So y hat is the predicted annual depression rate. The hat represents the predicted equals 0.3675 plus 0.01145 times x, but x is the refined sugar consumption amount. In statistics, we tend to write the response variable equals the initial value plus the rate times the explanatory variable. We use the explanatory variable to predict the response variable.